Our lesson for today is about the classification of polynomials. But before discussing our main topic for this day, let us first have a recap or review of our previous topic, which will help us to have a deeper understanding of our topic for today. 9x squared plus 6x minus 1 is an algebraic expression, right? And in this algebraic expression, 9x squared, 6x, and negative 1 are called terms. So if 9x squared, 6x, and negative 1 are called terms, how do you define a term? Very good. A term is a constant, a variable, or a product of a constant and a variable. In the algebraic expression that I gave to you earlier, we said that 9x squared, 6x, and negative 1 are called terms. And let's first look at 9x squared. In 9x squared, 9 is called the numerical coefficient, and x squared is called the literal coefficient. Now, let's look at the second term of the algebraic expression that I presented earlier, which is the term 6x. 6x has a numerical coefficient which is 6 and a literal coefficient which is x. The last term of the algebraic expression that I presented to you earlier is negative 1. The term negative 1 is called the constant, which is usually referred to as the term without a variable. Now, based on the terms that I presented to you, we identified the numerical coefficient and the literal coefficients. Based on those examples, what is now the definition of a numerical coefficient and a literal coefficient? Excellent! Based on those examples, we can say that numerical coefficient is the constant or number, and a literal coefficient is the variable including its exponent. Bear in mind that the word coefficient alone is referred to as the numerical coefficient. So, if I just said coefficient, don't ask me anymore if what I am talking is a numerical or literal coefficient. Because if I just said coefficient alone, it will automatically mean numerical coefficient. Alright, we said that a literal coefficient is the variable including its exponent. Let us look at the literal coefficient x squared. X is called the base, and 2 is called the exponent. With that, we can say that exponent refers to the thing that you can see in the upper right of the base. Now, let us also recall similar terms and not similar terms. Similar terms are terms having the same literal coefficients. Let's have an example. 2x squared and negative 4x squared are similar because their literal coefficients are the same. What are their literal coefficients? Exactly, their literal coefficients is x squared. This time, let's have an example of not similar terms. Negative 3x and 3x squared are not similar because their literal coefficients are not the same. What is the literal coefficient of the term negative 3x? And what is the literal coefficient of the term 3x squared? Precisely, the literal coefficient of the term negative 3x is x. And the literal coefficient of the term 3x squared is x squared. Thus, x and x squared are not the same. So they are not similar terms. The terms that we have recalled are the things that you should bear in mind, because you will again encounter these terms in our topic today and on the succeeding topics that we will discuss. Since our topic today is about classifying polynomials, let us first define the term polynomial. Polynomial is a kind of algebraic expression where each term is a constant, a variable, or a product of a constant and a variable in which the variable has a whole number or non-negative exponent. Actually, not all algebraic expressions are polynomials. How can we identify if the given algebraic expression is not a polynomial? Well, there are three things that you should remember so that you can easily identify if a given algebraic expression is not a polynomial. First, the exponent of the variable is not a whole number. By the way, what is a whole number? We learned in our previous lessons that a whole number is the set of numbers formed by adding 0 to the set of natural numbers. These are 0, 1, 2, 3, 4, 5, and the numbers to the positive infinity. So it means that if there is a negative sign in the exponent, then it is not a polynomial. Second, the variable is inside the radical sign. In order to identify if there is a variable inside the radical sign, the first thing that you should do is to look if there is a radical sign in a given algebraic expression. It is for the reason that if the algebraic expression does not have a radical sign, then you can already disregard this. Because if there is no radical sign, then it would automatically mean that there is no variable inside the radical sign. Third, the variable is in the denominator. Just like the previous one, in order to identify if the variable is in the denominator, the first thing that you should do is to look if there is a fraction in a given algebraic expression. It is for the reason that if the algebraic expression does not have a fraction, then you can already disregard this, because if there is no fraction, then it would automatically mean that there is no variable in the denominator. This time, let's have examples and let us identify if these examples are polynomial or not. First, let's have 1/2 x cubed minus 3.4x plus 7. It is an example of a polynomial, for we do not have a negative exponent. We have a fraction, but we do not have a variable in the denominator. Don't be confused. X cubed there is not in the denominator. The first term, 1/2 x cubed, actually means 1/2 times x cubed. And we can actually rewrite it as x cubed over 2. Also, we do not have a radical sign. So it is clear that we do not have a variable inside the radical sign. These are the reasons why this algebraic expression is a polynomial. Second, let's have 5x raised to negative 1 minus 3x minus 6. It is not a polynomial, for it has a negative exponent. And you don't need to worry anymore on the other things to consider disqualifying it as a polynomial, like the variable inside the radical sign and the variable in the denominator, because one counterexample to prove that it is not a polynomial is enough. This is now your turn. Try this. Tell whether the following algebraic expressions are polynomials or not. First, we have 9x squared plus 6x minus 1. Second, we have negative 5x squared plus x raised to negative 1 minus 1 over x. Alright, is 9x squared plus 6x minus 1 a polynomial? Very good, it is a polynomial. How about negative 5x squared plus x raised to negative 1 less 1 over x? Exactly, it is not a polynomial. What made you decide that it is not a polynomial? Alright, it has a negative exponent and it has a variable in the denominator. We can actually classify polynomials based on the number of terms. Here are their classifications based on the number of terms. First, we have monomial. It is a polynomial with only one term. Second, we have binomial. It is a polynomial with two terms. Third, we have trinomial. It is a polynomial with three terms. Fourth, we have polynomial. It is a polynomial with 4 or more terms. Bear in mind that polynomials with more than 3 terms have no special name, so we just call it polynomial. How can we classify polynomials based on the number of terms? Well, to identify an expression as monomial, binomial, trinomial, or just plain polynomial if it contains more than 3 terms, follow this procedure. First, look for plus or minus signs separating the terms. Although we defined a polynomial as a sum of 1 or more terms, any of those could be negative term. For example, 9x squared plus 6x minus 1. We can actually rewrite it as 9x squared plus 6x plus negative 1. If we want to go back to the definition of polynomial as sum of 1 or more terms. But 9x squared plus 6x minus 1 is actually the simplified form of 9x squared plus 6x plus negative 1. So in our example 9x squared plus 6x minus 1, let us look for plus or minus sign. And we actually have a plus and minus sign here that separates the terms. Second, make sure that there are no variables in the denominator of any of the terms, nor any variable under the radical sign. And in our example in the first step, we does not have a radical sign, so we can already disregard this step. Third, count the number of terms and name the expressions accordingly. Going back into our example, 9x squared plus 6x minus 1, We said in the previous steps that we have the plus and minus sign that separates each term, since we already identified it in the first step. We are now ready to count the number of terms. We have 9x squared, 6x, and negative 1. Let's count. 1, 2, 3. There are 3 terms. Therefore, it is called trinomial. Now, I will give you some examples of polynomials classified based on the number of terms. Let's have examples of monomials. We have 9a squared b, negative 8x, and 53. In these examples, there are no plus and minus signs. So it means that there are no terms to separate. And it implies that there is just one term. That's why these are called monomials. Let's have another set of examples, and these are examples of binomials. We have 5x cubed less 2x squared, 11x squared plus 4xy, and negative 14x raised to 24 plus 3. We can observe in these examples that there is a plus and minus sign between the terms that will separate it into 2. 5x cubed and 2x squared are 2 terms separated by a minus sign. 11x squared and 4xy are 2 terms separated by a plus sign. And negative 14x raised to 24 and 3 are 2 terms separated by plus sign. This is why these are called binomials. Let us also have another set of examples, and these are examples of trinomials. We have negative 8a squared plus 3a plus 4. We also have 28m raised to 4 less 3m squared less 4m. And negative 11x raised to 7 minus 4x raised to 4 minus 3x raised to 2. In these examples, the terms are separated by the plus and minus sign. So if you count the terms separated by the plus and minus sign, there are 3 terms. For negative 8a squared plus 3a plus 4, there are 2 plus signs that separate the terms negative 8a squared, 3a, and 4. For 28m raised to 4 less 3m squared minus 4m, there are 2 minus signs that separate the terms 28m raised to 4, 3m squared, and 4m. The same goes to negative 11x raised to 7 minus 4x raised to 4 minus 3x squared. That there are 2 minus signs that separate the terms negative 11x raised to 7, 4x raised to 4, and 3x squared. These are the reasons that these examples are called trinomials. This time, let us have another set of examples of polynomials. Let's have negative 30. The constant negative 30 is a polynomial and it is just a single term, so it is called monomial. Next, let's have the expression x squared minus 10. It is a polynomial and this can be written as x squared plus negative 10. As I said a while back, a polynomial is a sum of one or more terms, So we can rewrite it as x squared plus negative 10. But it is just the same as x squared minus 10. I am telling this so that you will not be confused, because there are some books that uses x squared plus negative 10 instead of x squared minus 10. While there are also books that uses x squared minus 10 instead of x squared plus negative 10. So in this example, there are two terms separated by a plus, which are the terms x squared and negative 10. Therefore, this term is called binomial. Lastly, let's have the expression 4x squared minus 6x minus 8. It is a polynomial and can be written as 4x squared plus negative 6x plus negative 8. It is just like saying that it is the sum of the monomials 4x squared, negative 6x, and negative 8. Since it does not contain fractions or radical sign, we can proceed to the next step, which is to count the number of terms. The given polynomial contains 3 terms, so we call it trinomial. You may be wondering on how our lesson can be applied in real life. Well, you've probably used a polynomial in your head more than once when you're shopping, but you're not just aware of it. For example, you might want to know how much 3 kilos of flour, 2 trays of eggs, and 3 packs of milk cost. Before you check the prices, you construct a simple polynomial. Now, what is the polynomial that you can construct out of the given? What kind of polynomial according to the number of terms is constructed? And suppose that a kilo of flour is 50 pesos, a tray of egg is 220 pesos, and a pack of milk is 115 pesos. How much will you pay? This is our solution. First, let F denote the price of a kilo of flour, E denote the price of a tray of egg, and M denote the price of a pack of milk. If we let F denotes the price of a kilo of flour, E denotes the price of a tray of egg, and M denotes the price of a pack of milk, what will be the polynomial form? Exactly! The polynomial form looks this way: 3F plus 2E plus 3M. How many terms are there in the polynomial? Precisely, there are 3 terms. So what kind of polynomial according to the number of terms is constructed? Very good. The constructed polynomial is a trinomial. Given the polynomial constructed, how are we going to determine the amount that you will pay? Very good. Let's substitute the given values to the polynomial constructed. 3F plus 2E plus 3M is the polynomial constructed, right? Remember that in letter B, it says there that suppose that a kilo of flour is worth 50 pesos. Again, this is just for a kilo, and you need 3 kilos. So, the polynomial constructed is aligned to the problem. Now, let's substitute 50 pesos to F, because we said earlier that we denote F as the price of a kilo of flour. So, we have 3 times 50 pesos. The same process goes to the tray of eggs and pack of milks. With that, we have 3 times 50 pesos plus 2 times 220 pesos plus 3 times 115 pesos. Calculating this gives us 935 pesos. Therefore, you will pay 935 pesos. This time, I will give you activity called Let's Make a Generalization. I will give you a Padlet link and you can either click the link or enter it in your browser to have an access to it. In that link, you can see questions to answer and you are to place your answers in the comment section of the post that I made in that online bulletin board. Here is the link of the Padlet or online bulletin board to access. When you open the link, you will be redirected to padlet.com and your screen will look this way. So it's time to answer the questions. I scanned your answers and you answered it right. It seems like you really understood our discussion for this day, and it implies that you are now ready for your short quiz. I am going to give you a link where you are going to have a short quiz. Again, you can either click the link, copy and paste it, or enter it in your browser. It is in Google form, so make sure that you have a good internet connection. And the direction for your quiz is given in the Google form. So make sure to read it first when you open the link before answering the questions given. If you have queries regarding your short quiz, just send me a message and I will respond to it as fast as I can. Here is the link of the Google form where you will have your short quiz. When you enter the link, your screen will look this way. And if you can already see the same as this in your screen, you can already begin your short quiz. Good job, grade 7 students! It is a pleasure to teach when you work like that. Now, I am going to give your assignment. So this is your assignment. It is called Scan and Solve. I prepared here a QR code. Using your gadget, you will scan the QR code that contains the problem that you are going to solve. This is the QR code to scan. Do you have questions? Since you don't have questions, you may now scan your assignment. Okay, you certainly did well today, class. I am so proud of you. So, let's call it a day. See you tomorrow, class.